these will take forever to defrost. Hey, let's just nuke it. Dear Tim and Moby, what does it mean when something is radioactive? From Inez. Well, first of all, microwave ovens aren't radioactive. Radioactivity is the emission of high-energy particles or waves from certain atoms. This energy emission happens when the nucleus of the atom partially disintegrates or falls apart. The process of disintegration is called radioactive decay, and it occurs in atoms that are unstable. Well, most atoms have stable nuclei. The number of protons and neutrons never changes. But a radioactive atom isn't stable. As it decays, the number of protons, neutrons, and electrons inside the atom changes. In other words, it turns into a completely different atom with different properties. Uranium-238 is a radioactive isotope of uranium. Oh, isotopes are atoms of the same element that have different numbers of neutrons. Uranium-234 is another isotope of uranium with 4 fewer neutrons. Anyway, uranium-238 is the most common isotope of uranium, and it's radioactive. When its nucleus decays, the uranium-238 turns into a thorium atom. The thorium eventually decays into proactinium, which decays into uranium-234, which decays... Well, anyway, long story short, one uranium-238 atom goes through 14 changes before ending up as plain old lead. It's impossible to predict exactly when a particular radioactive atom will decay. But a group of the same radioactive atoms is predictable. If you have a bunch of uranium-238 atoms, you can be sure that half of them will decay into thorium in 4.5 billion years. The time it takes for half of a group of radioisotopes to decay is that isotope's half-life. Well, radioactivity can be dangerous depending on the type of decay that happens. Some forms of radioactive decay throw off alpha particles, which aren't really harmful to us unless we put them inside our bodies. Other types of decay throw off beta particles, which can penetrate a few layers of our skin and do some damage. And some radioactive decay throws off gamma rays, the highest energy form of electromagnetic radiation. Gamma rays can burn our skin, penetrate our body cells, and even mess up our DNA. This can result in cancers and genetic mutations. Human activity creates tons of dangerous radioactive waste every year, and getting rid of the stuff is expensive and difficult. But nuclear radiation has been a big benefit to humans too. Nuclear power plants, X-rays, pacemakers, smoke detectors, and tons of other technologies rely on radioactive decay. It's a tough trade-off. Radioactivity is incredibly useful, but also incredibly dangerous. Oh, and by the way, radioactivity isn't just something that humans created. It occurs naturally too. Just about everything on the planet, from rocks to plants to animals, contains traces of radioactive elements. Oh, the hot dogs are defrosted. Oops, I think we left those in too long.
On the Earth, the main sources of alpha particles are unstable isotopes of heavy elements. One of these is uranium-238. As a result of continuous oscillations inside the nucleus, a group made up of 2 protons and 2 neutrons may become separated. The equal range of alpha particles in air implies that a given isotope emits particles of similar energies.
Beta decay is completely different from alpha decay. The emission of an electron from the nucleus is more surprising than the emission of an alpha particle, as there are no electrons in a nucleus. In fact, the source of electrons is provided by the process of neutron decay, which produces a proton and an electron. The proton remains in the nucleus, while the electron is ejected at a great velocity.
Radon-222 is being formed continuously in our environment by decay of uranium-238. Radon, being a noble gas, is chemically unreactive. Therefore, it is not trapped by chemical processes in the soil or water, and is free to seep up from the ground and into homes. Radon spontaneously emits alpha particles from its nuclei. Since alpha particles are attracted to the negative plate of an applied electrical field, they must be positively charged. A radon-222 nucleus contains 86 protons and 136 neutrons. During alpha particle emission, a particle composed of 2 protons and 2 neutrons is emitted. An alpha particle is equivalent to a helium-4 nucleus. When an alpha particle is emitted from a radon-222 nucleus, a polonium isotope, polonium-218, is produced. Since an alpha particle contains 2 protons, the atomic number decreases by 2, from 86 to 84. An alpha particle has a mass number of 4, so the mass number decreases from 222 to 218. The polonium-218 isotope produced is unstable, and therefore undergoes further radioactive decay. Carbon-14 spontaneously emits beta particles from its nuclei. Since beta particles are attracted to the positive plate of an applied electric field, they must be negatively charged. In fact, beta particles are electrons that are formed and then emitted from the nuclei of certain radioactive isotopes. In the decay process, a neutron is converted to a proton and a beta particle. A carbon-14 nucleus contains 6 protons and 8 neutrons. During beta decay, one of the neutrons is converted to a proton and an electron. This electron, called a beta particle, is then ejected from the nucleus, producing nitrogen-14. A nitrogen-14 nucleus is stable. Thus, no further radioactive decay occurs. Cobalt-60 is used for radiation therapy in treating certain cancers. It spontaneously emits gamma rays from its nuclei. Since gamma rays are undeflected by an applied electrical field, they have no electrical charge. Gamma rays are very high-energy electromagnetic radiation. They have no detectable charge or mass. A cobalt-60 nucleus contains 27 protons and 33 neutrons. When a gamma ray is emitted, the number of protons and neutrons in the nucleus is unchanged. The half-life for this process is 5.26 years. This means that half of a given sample will undergo this process every 5.26 years. Both alpha and beta particles are deflected by an applied electrical field, while gamma rays are unaffected. Also note that alpha particles are deflected less by the applied electrical field compared to beta particles due to their higher mass. An alpha particle composed of 2 protons and 2 neutrons is approximately 7,000 times the mass of a beta particle.
Suppose you've discovered an ancient bone amulet in an archaeological dig, and you want to know its age. You can use the rate of decay of carbon-14 to determine the artifact's age. The nucleus of a carbon-14 atom is unstable. At some time, this unstable nucleus will emit a high-energy electron called a beta particle, which has a 1- charge. The beta particle causes a neutron to change to a proton, and the carbon-14 atom then decays into a nitrogen-14 atom. The average time for half of a group of carbon-14 atoms to decay is 5,730 years and is called a half-life. Your bone amulet is found to contain only 12.4% of carbon-14. How old is the artifact? The level of 12.4% indicates that 3 half-lives have passed. 3 half-lives times 5,730 years is 17,190 years old. Carbon-14 samples can be accurately dated up to 60,000 years old.